This section finishes off the Newton's method, where we're going to talk here about other iterative processes and the learning outcomes to apply iterative processes to various situations. So just to refresh our memories, an iterative process is one in which the next value is dependent upon the previous value. We have a process to go through, an algorithm that helps us generate the new value. So let's see what we have here. Example. So we're finding a limit for an iterative process. We're going to see if this process will lead to a specific value, and they're calling that value this, at some x star is f of x star prime. That's the fixed point of f. So that's the limit that we're going to go to. So here we go. It says that f of x equals 1/2 x plus 4. And so the way we're going to set this up as an iteration is we have our x to the n equals f of x to the n minus 1. And so we're looking for n being greater than or equal to 1. X sub n is equal to 1/2 of x sub n minus 1 plus 4. So our x1 will equal what? Did they give us an x sub 0? Yes, they did. X sub 0, 0. So 1/2 of 0 plus 4 is 4. x2 is 1/2 of 4. That's the value from the x1. 1/2 of 4 plus 4 is 6. x3, 1/2 of 6 plus 4 is 7. x4, 1/2 of 7 plus 4 is 7.5. x5, 1/2 of 7.5 plus 4 is 7.75. x6 is 1/2 of 7.75 plus 4, and that's going to be 7.875. x7, I know they only said to go to x5, but I feel like we have to go a little further just to see where it's going. 1/2 of 7.875 plus 4 is 7.9375. x8 is 1/2 of 7.9375 plus 4, and that's going to be 7.96875. And then x9 is 1/2 of that 7.96875 plus 4, and you get 7.984375. So if we're looking for where it's going, it looks like this is approaching, x sub n is approaching 8. Now we can prove this. If we were to say, think about y equals x, the line y equals x, and y equals 1/2 x plus 4, and we set them equal to each other. So x equals, and that's the standard, as you set your equation equal to y equals x. X equals 1/2 of x plus 4. Then if you subtract 1/2 from both sides, 1/2 x, you get 1/2 x equals 4. Then if you multiply by 2, x equals 8. So it makes sense that that's where it's going. Okay, continuing on here. Consider f of x equals 1/3 x plus 6, where x sub 0 is 0. X sub n equals f of x sub n minus 1 for n greater than 2. So find x1, x2, x3, x4, x5, and then see where it's going. Okay, so our x sub n is equal to 1/3 of x sub n minus 1 plus 6. So our x 0 is 0. x1 is 1/3 of 0 plus 6, which is 6. x2 is 1/3 of 6 plus 3. I think I made a mistake. It is plus 6. So that's going to be, should be plus 6. That's going to be 8. x3 is 1/3 of 8. That's where it gets a little messy, plus 6. And that's going to be 26/3, which is approximately 8.67. x4 is 1/3 of 26/3 plus 6, which would be 80/9, which is approximately 8.89. Notice each time this is like the numerator is one less than something that needed to be divisible by 3. x5 is 1/3 of 80/9 plus 6, which is what? 242 divided by 27, which is approximately 8.96296. So x, if we were to solve this, see where, oh, I guess you can see where it's going. Looks like it's going towards 9. X sub n is going towards 9. So if you set x equal to 1/3 of x plus 6, subtracting 1/3 x from each side, 2/3 x equals 6. That's thirds. Multiplied by 3/2, x equals 9. Yay, that was fun. Okay, let's do one more. And this one they want us to use, didn't pronounce, so it's use Newton's method to approximate a solution of the equation e to the 0.2x squared plus x minus 2 equals 0. So we'll say that f of x is equal to e to the 0.2x squared plus x minus 2. Then our f prime of x would be equal to so it's the derivative of the e to the 0.2x squared. We're going to have that 0.2 come down. And then the derivative of the x squared is a 2x. E to the 0.2x squared plus 1. So that'd be 0.4 e to the 0.2x squared plus 1. Now, this thing can be expressed as x sub n equals x sub n minus 1 minus this e to the 0.2 x sub n minus 1 squared plus x sub n minus 1 minus 2 all over. And this is x sub n minus 1 minus this fraction. That 0.4 or e to the negative 0.2, sorry, not negative 0.2, it's just 0.2. 0.2 x squared plus 1. Now when I did this, I put up my calculator and I made it say y equals this. And then I used the table and I had it up it on the ask, not the auto. So I was able to start, and this one said to start with x of 0 equals 2. So by plugging 2 in, my x1 would be 1.19957 0306361, and then I took that number and I couldn't find a way to copy and paste it, so I just literally wrote this down and typed it in again for x2, and I got 0.874506978336. That's it. So they just want us to do 2 iterations. So, okay, hope that helps. That's the end of Newton's method. Yay.